In the laser eye protection filter world of a few decades ago, it was recognized that on this 2-to-1 filter, for example, that all of these harmonics had the same width in terms of delta wavelength or delta frequency, where now we're on a frequency scale. But when I go from that frequency to 9 times that frequency, the width divided by the frequency is now 9-to-1 what it was there, or 1/9, or the same thing on a wavelength scale. So I could get some narrow blockers for a narrow wavelength laser by using one of these higher harmonics. The problem with that is if I needed the 7th harmonic to get the width and the density I wanted, also came with it the 5th harmonic and the 9th harmonic. And maybe this one's no big deal, but that one might be troublesome depending on what you're trying to do. So people encountered this. I think they may still be living with it. I haven't heard anybody applied my approach, which is the following. I looked at these ratios, and when I looked at a 10-to-1, so this is a total of a half wave, but I've got 1 part here, 9 parts there, or a 10-to-1. And so this thing goes to 0 at 10 and then starts up again. But what I finally noticed was that the relative width of this and its wavelength is quite different than these out here. And this one is quite a bit narrower, although it's quite a bit shorter also. But I can get a narrower one, a narrower blocking band than the other technique. So I can generate a filter like this without those other bands.